All right, so last class we talked about how to find distance between 2 points on a graph, but really using Pythagorean theorem. So today we're going to pick up and look at distance formula and how this is an alternate method, but technically they're still related. So we did end up writing down the distance formula at the end of last class. So double check real quick, make sure that you have that filled in. So again, given any 2 points, x1, y1 and x2, y2, we can use the formula for distance between those 2 points as d equals, or distance equals, the square root of x squared minus x1, or excuse me, x2 minus x1 squared plus y2 minus y1 squared. So let's actually do the same problem we did last class with the same points, plug them into distance formula, and then look at how that relates to the work that we did before. So our distance still, as before, is between points 4, 5 and -3, -4. So I'm going to go ahead and label these. So I'm going to call my first point 4 and 5. I'm going to call that x1 and y1. And I'm going to call the point -3, -4. I'm going to call that x2, y2. And actually, give me a second. I'm going to go ahead and make this a thicker ink line so people can see that a little bit better. And so we're going to go up to 3. Alrighty. And so if we plug that into the distance formula, that means our distance is going to equal our x2, which we've already labeled as -3, minus our x1, which is 4. That whole expression needs to be squared, plus we've got our y2, which is -4, minus our y1, which is 4 as well, but a positive, all squared, and the whole thing is underneath the square root. And so now let's just simplify. So -3 minus 4, that's going to give us a -7. Still has to be squared. And we have -4 minus 4, which is actually, I have an incorrect number in there. Can you see where it is? Yeah, actually I put a 4 where I should have a 5 for that y1. So let me go ahead and erase that. And let's redo. Okay, so that should be -4 minus 5. And when I subtract -4 minus 5, that gives me a -9. Everything is still underneath that square root. And so let's go ahead and simplify that. -7 squared, if we were to go plug that into the calculator, we are indeed going to get 49. -9 squared, or -9 times -9, is going to give us 81. And then we need to go ahead and add that together. And wait a second, these are the same values we had before. We still get square root of 130, just like we had in our original problem. So let me zoom out a little bit so we can see more things at one time. So compare your work. So when we did this with Pythagorean theorem, we had c squared equals 7 squared plus 9 squared. And if you look down at your distance formula, underneath our square root, we have, while they're negative numbers, we still had the same kind of thing going on. And so when we squared that out, you'll notice, again, at the top piece, we have 49 plus 81, whereas on the bottom, we still ended up with that 49 plus 81. It is exactly the same kind of picture. Give me 2 moments. Okay, sorry for the blip, had to answer the door. So again, we still have the same numbers that we're using. And in fact, this distance formula is derived from Pythagorean theorem. If you think about how we found our distance, when we were up here looking at how far it is between our 2 points in the horizontal, in other words, in the x direction, we can find that distance by just subtracting our x coordinates. And same thing, our distance in the vertical direction, we can find that by just subtracting the vertical values. So the 5 minus the -4, or the -4 minus 5, you subtract, you're finding that difference, or in other words, how far, what the length is between those 2 points on a number line. So in fact, distance formula is the same thing as using Pythagorean theorem. So why would you use one over the other? Well, what if you have really large coordinates and you don't want to take the time to count all the spaces all the way across? Well, you can plug them into distance formula and it'll do the same thing. So let's look at a few more example problems. And so how I have it set up on here is for each one of these problems, I have where we can set it up with distance formula and we can check it with Pythagorean theorem. So I'm only going to do that actually for the first one, but I put a spot where you could do that for all the rest of our examples. So if you want to, please go ahead to double check. It's a great way to check your work is to use two different methods on the same problem and see how they compare. So let's go ahead. I'm going to bump this up so we can see it better. First problem, we're going to use distance formula and Pythagorean theorem to check this problem. So here we go. For number one, excuse me. We need to find the distance between points A and B. So here we go. I'm going to call A, our 0, 0 point. I'm going to call that x1 and y1. I'm going to call 6, 8, x2 and y2. And let's plug it in. So our distance formula, I'm actually going to copy the whole distance formula for this first one. We have x2 minus x1 squared plus y2 minus y1 squared. So we fill in our values as we have them labeled. Our x2 is 6, x1 is 0, square it up. You'll notice I wait to write my square root because I want to see how everything lines up so I don't run out of room. Y2 is our 8 minus y1 is 0, square it. And then we simplify, always go to the inside of the parentheses first. So we have 6 minus 0 is just 6, but the whole thing is still squared. 8 minus 0 is still 8, but it's all squared. And then we square those. So we have 6 squared is 36, 8 squared is 64. And you add those together, you get the square root of 100, which is one of our perfect squares, which means we have an exact distance of 10 units between these. So let's real quick check that with Pythagorean theorem over on the side. So we had our 2 points, 0, 0 and 6, 8. So 1, 2, 3, 4, 5, 6, and then up 8, 1, 2, 3, 4, 5, 6, 7, 8. Let me just double check. 2, 4, 6, 8. There we go. So we have our point 0, 0. We have our point 6, 8. We're looking for the distance that goes straight in between them, but we need the sides of our right triangle. So straight across until we're right underneath our point. This one's easy to count since we're starting at the origin. And we have our coordinate for our other point 6, 8. That means I know I have to go over 6 and up 8 to get there. I don't even have to count it again. I already did the counting. So then with Pythagorean theorem, we're trying to solve for C. So again, you can set it up a squared plus b squared equals c squared, or you can do c squared equals a squared plus b squared. We substitute in our values of our sides. I'm going to use 6 as my a and 8 as my b. So c squared equals 6 squared plus 8 squared. And the math comes out the same. 6 squared is 36. 8 squared is 64. Add those together, you get 100. To get the c by itself, what do we need to do from last time? And we need to take our square root. Again, I'm going to try to go through bigger ink so you can see it better. So we take the square root of both sides. And so that then simplifies out. C equals 10. Our work checks out. Okay, I'm going to go ahead and run through the next 3 examples. But again, I'm just going to do distance formula. So on your own, if you want to check your work, go ahead and run it through Pythagorean theorem if you like to see if you get that same answer out. If you get it both or using both methods, then you are doing your problem perfectly. Okay, problem number or example number 2. So we have point R is -2, 5, point S is 0, 9. We're going to use distance formula. Actually, with this one, just to preserve space, I'm going to label my x1, y1 above it. Again, it's not something you have to do every single time, but as you're starting out, it's not a bad idea to write in those labels, just so you can keep track of which one you're plugging in. So again, in my formula, I'm not going to write the formula out again. I've now written it a few times. You can always start by writing it out first step. Feel free to take that extra time. It takes an extra 10 seconds that I probably could have already done in the time that I explained. But that's okay. I'm going to do x2 is 0 minus x1 is -2. plus y2 is 9 minus y1 is 5, whole thing square root. Now you can see why I usually wait to write my square root, just to make sure I have enough space on there. So let's do our subtraction. The thing is that first one, 0 minus negative 2. What happens when you subtract a negative? Well, yeah, it's really the same thing as adding a positive. The negative signs almost cancel each other out. So really, we're going to do 0 plus 2. So then that comes to 2. Still has to be squared. Plus 9 minus 5 gives us 4, which is also still squared. Whole thing under the square root. Simplify that, we get a 4 plus 16, which simplifies to square root of 20. And here's where we need to make the decision. So we talked about this, I believe, in class last time, that the square root of 20, yeah, you could plug it in the calculator and get a decimal. And in fact, when you do that, it's not too bad of a decimal. It comes out as 4.4721 approximately. But let's get more exact. So don't forget, you can reduce that radical. So think about dividing it up. He actually factors out to a 4 and a 5. And the nice thing about that 4, that 4 is a perfect square. Excuse me. And so because I know that's a perfect square, when I rewrite my answer as a simplified version, square root of 4 is 2, so he goes on the outside. 5 did not pair up with another factor. And so actually any of these would be appropriate answers. We could leave it as square root of 20. We could leave it as approximately 4.4721, or we could leave it as the exact answer, 2 root 5. It depends on the problem that you're working on as to how it may want you to leave your answer. Pay very close attention to the directions on the practice that you're about to do. Alrighty, if you want to try the next two on your own, 3 and 4, go ahead and pause the video real quick, try out those problems, and then start this back up to see how you did. All right, let's see how 3 and 4 went. So again, I think I'm on blue ink. Okay, so x1, y1, x2, y2. Notice the x's are always coming at the front of your coordinates. Be careful. If you have a tendency to flip these around by accident, take this step and label which ones are which. Okay, our distance is x2 is 9 minus x1 is 1 squared, plus y2 is 13 minus negative 4, all squared, and all under the square root. So we have another one of those. Minus negative is really plus a positive. So to simplify out, 9 minus 1 is 8, still squared. 13 plus 4 is 17, so 17 squared. And I'll be honest, this is where I got on my calculator. 17 squared is not one that I have memorized. So you can always pull up Desmos either on your computer or your phone if your substitute is worried about you having a phone. Replay this part of the video as long as you're using your phone as your calculator. But when you do square those out, you're going to get 64 and 289. Add those up, you will get 353. And unfortunately, 353 is a prime number. Or rather, I don't know what the factors are right off the top of my head. I don't have them written down on my work, but I do know that when I went through to figure that one out, either it was a prime number or it was composed of prime numbers, so we couldn't break anything down. We can write it as a decimal though. That is approximately 18.7883. So again, depending on the directions on your practice, either one of those would be an appropriate answer. Alrighty, last problem, number 4. Sorry, trying to exit from the ink. There we go. So problem number 4. Again, x1, y1, x2, y2. This is one that I would definitely tend towards just using distance formula because you'll notice your values are pretty large. So you are going to have a little bit of a distance in between them, but that's okay. So your distance equals negative 9 minus negative 12 squared plus 6 minus 2 squared. Simplify in your parentheses, simplify your group. We have another minus a negative. So negative 9 plus 12 is going to give me a positive 3. 6 minus 2 is going to give me a positive 4. Those simplify to 9 and 16. And when I add those up, I get 25 under the square root. That is a perfect square. My answer for this one comes out as exactly. So some reminders as you're looking at these problems. Don't forget, if you can reduce the radical, if you remember how to do that, practice it. Make sure you don't lose that skill. But we are going to review that a little bit later as well. You can always check it against a decimal answer on your calculator. Second piece to remember, if you do have to convert it over to a decimal, don't forget to check your rounding. Be careful. And again, your directions may say to round to the nearest 10th or the nearest 100th or the nearest 10,000th with 4 places on it. But you can leave it as a radical, especially if you notice that the number under the radical is something like a 13 or 211. What's special about those numbers? Yeah, those are both prime numbers. So unfortunately, they wouldn't factor out anyways. So absolutely the most accurate way is to leave it as a square root, unless the problem tells you to put it into a decimal. Go ahead and boot up your computer. You're going to work on the Delta Math Practice 1A. Again, if you do not yet have an account for that, please follow the directions that the sub will give you. I'll probably have that up on the board as well. But you can also find the directions in Schoology under course information, and then go to the geometry tools sign up. And there are directions in there specifically for Delta Math. Make sure to click on your class to set that up. I will see you next time. Please make sure to keep track of any questions. We can answer those next time if you still have them. Have a great day.